Okay, so volume of a pyramid or cone is pretty much just like volume of a prism or cylinder. The only difference is you throw a 1/3 out in front of the formula. So again, capital B is area of the base, so it will change depending on the shape of the base. So find the volume of a rectangular pyramid. Rectangular means the base is a rectangle with a length of 11, width of 18, and a height of 23. So if volume equals 1/3 area of the base times the height, and area of the base, if the base is a rectangle, is length times width, then you're looking at doing 1/3 length times width, and then the height is 23. You should be able to multiply all those. I would just do 18 times 11 first, then multiply it by 23, and then either multiply by 1/2 or divide by 2. Or not 2. Multiply by 1/3 or divide by 3. So you should get 1518. 1518. Now you can type it in just like this. You just don't distribute that. A lot of people think you distribute that, and you don't unless they're being added, which these are all being multiplied, so you don't distribute it. Okay, find the volume of a pyramid if the height is equal to the apothem of the base. So first we got to find the apothem. So volume is 1/3 area of the base times the height, and if the base is a regular polygon, then volume is 1/3. Then we have 1/2 perimeter times apothem, then times the height. So hopefully you remember on a hexagon this is 30 degrees. So you take half the side, put it here, and multiply that by radical 3 to get the apothem. So you have 6 radical 3. Now it doesn't say if we find exact or not, so we'll have to just see. Okay, so we have 1/3. Oh, sorry. 1/2. The perimeter would be 12 times 6, which is 72. The apothem is 6 radical 3. Then it says the height is equal to the apothem of the base. So the height is also 6 radical 3. I guess that's why it didn't say, because those will actually cancel out. So honestly, I would type that entire thing in your calculator. And it might take a lot of parentheses, but I think that would just be easiest. So that's what I'm going to do. So I end up with 1296. Let's hope that's right. Yeah. Oh, that was a lot of work. Okay, find the exact volume of a cone. So a cone is the same formula, 1/3 area of the base times the height. If the base is a circle, then for area of the base you will do pi r squared, because that's how you find the area of a circle. So we have 1/3 pi 16 squared times the height. Sorry. We do not have the height. We have the slant height. So to get the height, you have to do h squared plus 16 squared equals 34 squared. Unless you know your Pythagorean triples, because it is a triple. But I'm going to go ahead and subtract 16 squared. Now you have to actually square those. You cannot just subtract 34 and 16. So do 34 squared minus 16 squared in your calculator. And you should get h squared equals 900. Take the square root of both sides and h equals 30. So then you can plug in your 30 here. Now it says exact, so we don't multiply the pi in our calculator. You just do 1/3 times 16 squared times 30. And I got 2560, and then we put the pi with it. Perfect. Okay, this lesson's kind of short, so I think we just have 2 left, yeah. Okay, so find the exact volume of the composite figure. So this would be a cone plus a cylinder plus a cone. So this is exact, which means we leave the pi in the answer. I'm just going to get rid of that so we have more room to work. So we do cone 1 plus cylinder plus cone 2. So volume of a cone is going to be, 1/3 pi r squared h. A cylinder is just base times height, area of the base times height, so it's just pi r squared h. And then this one is again 1/3 pi r squared h. But these r's, well, the r's are all the same. The radius is all 21. The height will change. So for this top cone, if this part's 35, we would do 70 minus 35 to get just this height, because the whole thing here is 70. So this height right here is also going to be 35. But this one's 40. And this one's 35. So we have 1/3 pi 21 squared, and then the height of that one's 35, plus pi 21 squared times 35 for the cylinder, plus 1/3 pi 21 squared times 40. So 21 squared times 35, and then times 1/3. For the first one gives us 5,145 pi. That's for this part right here. Plus 21 squared times 35, 15,435 pi for the middle one. And then 21 squared times 40 times 1/3 is 5,880 pi for the last one. This is going to be a huge number. So then these three behave like, or the pi's behave like variables. So it's just like if you had an x instead of pi. You just add the numbers in front. So I'll add 5,145 with 15,435 and with 5,880 and get 26,460 pi. And boy, I hope that's right. I like it when we get it right. All right, so this is a you try. I'd really like it if you would try this. So pause it and try it, but I'm going to go ahead and work it. It says exact again. So this is going to be a rectangular prism, and that's a hole. So minus a square. Well, that's not a square, that's a rectangular pyramid. So the rectangular prism is going to be length times width times height, because this is capital B, area of the base is length times width, and then times the height. Then this one's 1/3 length times width times height. So length, I'm going to call the bottom of this the base. So length times width would be 25 times 12 times the height is 15. Then minus 1/3 times 25 times 12 times the height, which is 15. So 25 times 12 times 15 is 4,500. And if I do that again, but times 1/3, I get 1,500. So if I subtract those, I get 3,000. Perfect. That's actually not too bad. And that's all there is to volume of pyramids and cones.